Welcome to Xilinx ML Suite video session. There are two major approaches, that is AWS acceleration and Nimbix acceleration. So we are going to accelerate Nimbix cloud. So you can go to this link. We can go to new tab. So in this Nimbix acceleration, so there is VCU1525 based development platform and the Alveo platform, so we can utilize any of one. So AWS have H2F1, so that is quite different, but which consists of partial touchable plus FPGA is the VCU1525, and the hardware level is this, and in the upper level, that is upper level of hardware, there is xDNN architecture. So xDNN is the deep neural network architecture, which is like the hardware architecture and which works on this FPGA platform. So xDNN architecture supports different type of frameworks like TensorFlow, MXNet and Caffe. So on these frameworks we can utilize any of the language, like we can utilize Python or we can utilize RESTful API. So this is the main design paradigm. So on the top, so we can have our application. So let's see some details, and the project is also available at github.com/Xilinx/ML Suite. So you can also visit this. So here is a bit more explanation about the xDNN architecture and how the community based framework and application works. Even there is GoogleNet, MATLAB, Julia, Python, JavaScript, R, Scala and other language supports with this flows, that is TensorFlow, Caffe and MXNet. So there is also the white paper WP504, which is acceleration of DNNs with xDNN. So let's go to here, and we already go through the getting started. So this is the getting started. Sign in on it, and let's place the password. And let's go to login. Actually, we are in Xilinx ML Suite shop page of the Jarvis. So Jarvis is the main application platform of Nimbix. So we just followed this link, and we are now at here. So this already sorts the Xilinx ML Suite option for us. So there are two different design methods. One is Xilinx ML Suite, which is normal ML Suite. This ML Suite consists of VCU1525 development architecture, where we are going to run the ML Suite from GitHub and utilize the or implement different application on it. Another is Alveo U200 development kit, and this kit also available on ML acceleration, so we can accelerate our machine learning application with this kit. So let's first see the ML Suite. Let's click on it, and this is actually VCU1525 architecture, and we can also get more from this Xilinx ML Suite. And this provides the Jupyter Notebook interface. Jupyter Notebook is a user-friendly interface for Python development. So let's go to Notebook, and we can select the machine type. So this is the VCU1525. There is only one machine and specific codes, and here is the rate. So even we can go to other optional properties, like we can determine the IP address, other things, and we can even set up the storage type, read only or force, and here we can see the submission types. So let's go to general again and let's click on submit. So this is the Anaconda end user license agreement. So Jupyter is installed with Anaconda, so Anaconda agreement have to be agreed. After it setups, our server will start, and the server will be of VCU1525, and these are our past work. We have developed the SDXL development tool for Hello World application, and we have run that Hello World application on Alveo U200 card. And let's connect it. Okay, our Jupyter notebook is opening, so it is like a normal notebook, just we are running it on VCU1525 based development platform from Nimbix. So we are going to first see some basic stuff, so basic projects. So we also have opened the project here. So this is the main ML suite GitHub link, which is already installed on our current VCU1525 platform. And let's just close it. And inside that, inside this ML suite, Xilinx ML suite, there is notebook. And actually we are getting this application inside this Jupyter interface. So these are the same, and here are some installation process which is already followed for installing this Jupyter notebook Nimbix server, Nimbix PC125. So we are going to see the object detection Yolo application, which is Python application, and we are going to run this application and see the outputs, and it also provides some comparison of CPU and FPGA optimization time and resources. So this is the application. Actually this application is used, but we are going to just show you the basic process, how to run it. Actually the running process is not quite complex, it is very much easy. So let's go to home, let's see this, or we can also go to other documents and let's click on object detection with Yolo. Yolo is the framework. So for this interface, first of all we are going to, or the application is going to import the libraries for xDNN, and the cafe is also included, and the Yolo design framework will be initialized on. So here are some details about this. Actually these details also can be accessed without Nimbix. That means this project is already available on GitHub, so you can just visit this GitHub link and can study about this project. So all the things are explained here. The main thing we are doing here is just running that application on VCU1525 development environment. That's all. So here are some details. Actually we are going to detect the objects from the given image, so it will classify and it will run the object detection algorithm on that image. So in the static image we have few objects, so we will utilize this object detection algorithm with Yolo to detect and identify the objects. So it utilizes cafe and darknet. So everything is explained here, and this is the comment section or the information section which not need to be compiled. If you want to run or compile, then you can just click on here. Let's go to model preparation section. This is also informative, and this is the first section which need to be compiled. So let's on it. It just import the libraries and necessary xDNN functions, OS, system, CV2, time IT, and the print functions. There are some details. It's actually running still. You can see the status here. Run has completed, and it actually set up all the necessary libraries. It imports the libraries and DNN files. So you can see ML suite has been imported in this section, and these are the background for CV2 and other Python libraries, and here is non-maximum separation libraries and darknet cafe libraries. So you can see the current directory information and the other environment setup information, and we can do next, and this is also information section. We can do again next, and this is the configuration section. So we are running a Nimbix cloud with VCU1525, so it can identify which system we are running with. So we are running a Nimbix. Actually the code, the project, this project is Same for AWS Cloud, AWS EC2 F1, and the Nimbix. So we are running on Nimbix currently. So it identify the Nimbix, and this is the input image which we are going to provide on. So we can do next, and now we have to run the darknet. So let's run it. So it determines the layers, and Yolo is implemented with. So we can see the weights and configuration file are loaded from the library file, and we can see the status of it, and the cafe module has been saved to the corresponding directory. So now let's again do next. This process is passing arguments and defining the compiled instance. So let's again do next, and it gives us the details of the layers, network, and the number of resources it is consuming on. So we are using 2056 TSP, and memory elements, etc. So here are some computing memory elements, dynamic memory schedules, output schedules, xDNN command files. Now let's create a quantizer and pass the arguments to the neural network. So we just run the information section, comments. So let's run the main section. So it is heading into the network, and calculation is processing, and all the image classification is done within now. So after it completes, we are going to just declare the model and get out. Okay, it is still running. Actually, we are running this all the process on VCU1525 of Nimbix, so you will not get confusion, because Jupyter is compatible with your own PC or everything. Like you can also do similar type of work, not exactly similar, but Jupyter can be installed on your PC also, but the acceleration will be different, the library will be different for this type of work. However, you can also install Cafe and the necessary libraries on your PC, and you can do all the things which we are running in VCU1525. We are just accelerating the application. So VCU1525 or Nimbix server or the Xilinx FPGA process the object detection algorithm with Cafe much faster than the normal CPU did. So we are going to open the handle for FPGA communication. So it will check the FPGA. So it has created the handle, and let's apply the model in the FPGA. That is weight is going to apply in the FPGA. So it is loading weights, bias, and parameters to the FPGA. So the xDNN architecture run those parameters and implement the neural network. So it is completed. Let's do next, and some memory allocation is here, and some memory allocation output. So memory sizes and elements are explained here, and xDNN processing engine on FPGA is going to optimize. So it also provides the microcode running time, and we're going to run the Yolo on CPU. So CPU also there. So it takes 5.77 milliseconds, and NM is also executed on the CPU. So I'm going to print out the results. So this is our final output. So most of the objects from person to the animals like the horse and traffic signals are detected. This is also, we can close the handles, and this commands close the handles, and we can close up. So the process has been closed. So this is all the basic of implementing object detection algorithm with CAFE on VCU1525 and using the darknet and Yolo. So let's go to home, and we can also try out other applications also, and we're going to just stop this Jupyter notebook from here. So we can torment or stop or shut down from here. We can shut it down, force shut down, we can do yes. So the basic object detection with VCU1525 has been accomplished. So we did the test. That's the available example design. We can also write up our own application using normal CAFE or TensorFlow design methodology with Jupyter. So there is also TensorFlow with the Jupyter, so we can also apply those type of applications. So you can explore other applications like quantizer CAFE, image classification with CAFE, and compiler CAFE. Most of applications are based on CAFE. However, you can also see how to install TensorFlow and utilize TensorFlow library for object detection. So the process has been terminated, and it gives us some results. So we can download the results. So we can see the details of what the process which we have followed on VCU1525. So this is all the acceleration of ML suite on VCU1525. Let's back to compute. So we already did this process, and now let's go to ML suite Alveo U200 development kit environment. So this is the VCU1525 and this is Alveo U200. So let's start with ML suite Alveo U200 development kit. So let's click on it, and the previous VCU1525 interface is Jupyter interface, notebook interface, and this is the desktop interface. What we have to do is we have to run the ML suite application on U200 manually. So this ML suite application have to be cloned, and we can do the process. First of all, we have to clone this, download the overlay, and install Anaconda, then we can do the process. So let's just see up some basic setup here. So this is Alveo U200. Let's submit it and let's agree on it. We will get the application started here. So it is starting, and you can see the compute time and the CPU time and wall time and the price or charges it accumulates. The user interface of this Nimbix dashboard is quite easy, so we can connect now. Let's also see the compute section. Compute section, we have currently the ML suite section. However, we can also sort by vendors. There are a number of vendors. We are targeting the Xilinx, so you can see Xilinx, and there are lots of applications along with other Alveo and SDXL. Let's again go to dashboard and let's go to click connect. It is opening the Ubuntu desktop server, so we can just follow this step. Here is the user guide which we can follow.